what I think of when I think of these, when I look at these problems, I want to think of kind of the blob that is being outlined here. There are two different questions. There's a question of how we want you to approach it, and then there's the question of how does the computer generate what it is considering as the correct answer. So the computer is using a different method than what you're going to use. It's using some sort of calculator, and it's coming up with what is considered a correct answer, but then it has a tolerance of error. So, you don't have to have their exact answer, but you have to have their exact answer within some margin. The algorithm that a computer is using to generate, it's saying, okay, here's my generic line, and it's doing this for lots and lots of different lines, and then it decides which out of all those is the best. So it makes some generic line, and then it considers, okay, what is the vertical distance? So if I draw a line straight up or straight down from each of my points, what is the vertical distance from all those? Then what it does is it takes those distances, and it doesn't just add all those distances up, it squares those distances. And so I'm not asking you to be able to implement this, I'm just trying to give you a general idea of what's going on in the background. Of how the computer is coming up with a correct answer. And so if I square a number that's bigger than 1, that number gets bigger. If I square a number that's smaller than 1, it gets smaller. And so it squares all of these numbers before it adds them together, and then it wants the smallest number out of all the different lines that it could pick. And of course, we're really not worrying about how the computer could actually implement that, or how you could implement that in a statistics class. But the point that I'm trying to make is that because of this squaring thing, the points that are far away matter more than the points that are close. It might take several close points to give us the equivalent of one big point. And so I'm not just worrying about counting points and make sure I have the same number of points above and the same points below. I'm trying to take that blob and I'm trying to cut that blob in half. And so in my mind's eye, I've drawn that blob, that yellow blob that I have there. And I just keep drawing lines until I feel like I basically cut that blob in half. So I will just keep drawing lines. And I'll be like, oh no, there's a bunch of points up on top, far away, and there's not very many points below. And so I have to undo it. I keep drawing my line until I come up with one that I'm happy with. And so that's getting about as, I'm getting there with those lines. What I'm looking for is I am looking for points on the grid that go through the line. So if I can find any points on my line that actually go through the grid, and it might be better to try to find some that are kind of on the ends as far apart as possible. Or maybe if I feel like I know that it went through the halfway mark, maybe I'll go ahead and say that one's close enough. So if I can figure out 2 points on my line for which I know the coordinates as closely as possible, and that little pencil tool I have found is useful. Because the pencil tool, if you drag it to the point on the line that you're interested in, it will actually draw lines all the way to the x-axis and all the way down to the y-axis. So it helps you see that is the 0.27. But I can see that that's the 0.83. Okay, I'm going to go ahead and show you my preferred way of doing it. If you know how to do it the other way and you're really good at it, then go ahead and stick with it. But based on the mistakes that I've seen students doing over the years, for my business calculus students and then now you guys, I prefer to start with point slope form, just so that I don't see the mistakes happening that I see happening otherwise. So I would put the 7 here and the 2 here and the negative 2/3 here. I'm going to go ahead and do 2 steps at once. So I've got negative 2/3 times x, negative 2/3 times negative 2, and then I'm going to add a 7 over. And so I've got positive 4/3 and positive 21 thirds, so I think I get positive 25 thirds, and it helps if you don't forget your x. And you guys can use your calculator to do fractions. So I would have y equals negative, I tend to round to 2 places for these. So negative 0.67x plus, that's 8 1/3, so 8.33. If the problem didn't tell me I needed slope-intercept form, I wouldn't have gone to the work of putting it into slope-intercept form. But this problem does want me to do it. And then you'd plug your number in. One of the things that I double check, so I'm looking for arithmetic mistakes. So I look at my y-intercept. And so according to my equation, my y-intercept was supposed to be 8.33. And so I see that I haven't made, my line does seem to go with my points. My equation does seem to go with the points that I picked. So I just, again, a little way to just double check and see if you catch silly mistakes. Because I make lots of them. And then you would plug 4 in, double check 4 that it's 4 hours texting. Make sure that that is really an x value before you plug it in. So you get what, 5.67? Does my answer 5.67 seem reasonable for 4 hours? So I'm looking at this part of the graph.